Welcome everybody. I will be changing the gears a little bit. Everybody was talking about data science and uh, and and cloud and how to do workflows for data. I will talk about security and how to make data make his websites and web application more secure. So briefly, who am I? I am Mohamed ElKalioby. I am a Python developer for more than 10 years now, and I am in the same time a Django developer for more than 5 years. So the idea today we are going to talk about is, are passwords enough? And I like people to share with me. So if you like to just over mic or by chat, if you can tell us, do you believe that passwords are enough to protect websites? So please try to engage. So I believe everybody knows that passwords are not enough because passwords can be hacked. They can be key locked if you are trying to access from a public PC. They can be fetched. So everybody tries to get your username and password by fake sites. And in the same time, they are repeatable. So if, for example, your Facebook password has been hacked, most probably it is the same password you are using on Twitter. So the security principle that has been widely used for the past few years, that the user should be defined by something he knows, like a password, and then but something he has like a security, like a key or an access card, and something he is like a biometric, like his fingerprint, his retinal finger detection, or by face recognition. So but this is not very easy to do on a website because the user is remotely trying to access the website. So the common solution was to use an MFA, which is a multi-factor authentication. So the idea is asking the user to provide, to validate, to verify that his identity using another verification method after a correct use password entry. So the most common techniques was to use a custom-made MFA device like the one shown here, which have been used by PayPal previously in the 90s and early 2000s, that, or to use a one-time password over SMS, like with most of the banks use to verify that the user is having his own mobile phone. But in the same time, this is a little bit expensive to send a password for the user every time he tries to log in, or to have a custom made device is expensive. So cannot we find a cheaper solutions? The wide known solution is the Authenticator apps. It is asymmetric encryption. The application on your phone and the server has the same shared key, and the password change based on the time. And the password shown here will be valid for only 30 seconds. And after 30 seconds, a new password is required. Or to use a security device. This is like as a custom made MFA device, but the idea here is that this security device can be shared between multiple services, and it's at the same time it is asymmetric. So the value on the server is different from the value you should provide to be able to log in. And on the web, it's used to have the what's called the Universal Second Factor Protocol, UTF. And but in the same time, this protocol has some gaps that needed to be updated in the last years, because it was depending on a JavaScript file and it was not part of a browser API. And in the same time, it was only designed for security keys. So it was only working for Ubiquitous security keys and the Google Tatans. And in the same time, most of us now have smartphones with fingerprint sensor, iris detection, and facial recognition, but there is no way to use this as a second factor authentication. We are asking users to have a better security for websites. They need to go and buy these security keys. So the idea of the Web Authentication API was emerged. Work started in 2016 and it became a working standard in 2018. And it is an extension to UTF protocol that will provide passwordless authentication or a secure second factor. So now even we are trying to get rid of the passwords, the user has to log in using his username and the key directly without the need of passwords and a second factor. And the most important thing that the authenticator will be responsible about verifying the relaying parts, the website itself. And this is the most important step because this will protect against phishing attack. Because google.com will not be like Google Googl.com. The authenticator will detect it automatically. So what is the currently supported authenticators? From the left, you can use the security keys on Chrome and Firefox or Edge or Safari, on Mac, on Windows or Linux. So all of this now is supported. If you have a Windows Hello, you don't need to buy any more thing. You can use your fingerprint, your PIN, or your face, like you are logging to the Windows to be authenticated on the services. If you are having an Android, you can use your fingerprint, you can use an iris detection or a face recognition with the security keys to be able to log in from your Android device. And if you are having a Mac, Chrome was the first one to support the Touch ID on Mac 70 Plus. Currently, Apple has support for it on Safari on Mac OS, and the iOS, which is the iPhone, the iPad, is currently have support on on iOS 14 for Touch ID, but still the clients are being supported on the server backends. So how the registration flow works, it is pretty easy. The application starts with the application requiring to add a new authentication method. So the server sends the server info, the site info, the user info, and a challenge, which is a random value. The browser asks the user to select a device and forward the info to it. And why that it's try to select a device? Because, for example, on the Android, you can use the USB, you can use a security key or your fingerprint sensor if you have one. Then the device will prompt the user to verify the request, and by validating his identity, and then it generate a key pair, which is a private and public keys. Then the device sends a public key and the signed challenge using the private key back to the browser with the device information. The application sends the info back to the server, which the server finally will receive the information and decrypt the received challenge with the public key and validates again the sent challenge. So we started with a challenge. We received the challenge back with the public key. So we try to decrypt with the public key. If we get the first challenge we started with, we will assume the process complete and successful. How the user will log in? When the user wants to log in, the application requests a login to the service. The server sends a challenge. The browser again asks the user to select the device and forward the site information and the challenge to the device. The most important step, the device validates the site's identity first and then asks the user to validate his identity. Once the user validates his identity, the device sends the encrypted challenge and the device information to the browser, who in place will forward this information to the server, and the server will decrypt the received challenge using the public key it already knows for the device, for the user on the server, and make sure it is the same as the sent one. If it is everything okay, then we assume that this is the user identity. Which browsers is currently supporting this? Most of the browsers except IE, because IE has been stopped supporting and development for a long time now. So most of the browsers, even Safari on iOS, as shown here, has ability to use security devices since 13.3. Finally, this is very good security technique. But how can we use it in Django? Simply go use Django Mfa2. The Django application that handles MFA, it's available on Pep and Conda. It has been downloaded more than 60,000 times with around 2,000 downloads per month. And here is the link on how to access the package. And what is the features it supports? It simply supports TOTP, which is the authenticator devices, the time-based one-time passwords, universal second factor, web authentication API, email tokens, like when you want to send an email to the user to validate their as identity, trusted devices. Trusted devices is a mode to support devices that cannot work well with security keys or a fingerprint. Like if you have a budget Android phone, so it doesn't support any of these. So the easiest way for the user to be able to use this device to make it as a trusted device. And it allows passwordless access to the web authentication API. So if you like as a developer to allow users to just log in with just their username and the authentication, can be done. And it supports a client-side verification in JavaScript, which means that you can ask the MFA library to validate the user existence. If the user is valid, then or is still existing on the service, you can do something. If not, you can do something else, like accessing to most confidential data, like patient information, for example, and this kind of stuff. And for me to sum up, We discussed the multi-factor authentication and why it is important. We discussed the Web Authentication API briefly, and we showed how to use the Django API, that there is the Django Mfa2 library to use the Web Authentication API in the Django projects. Now I'm done and I'm open for questions.